So after we've entered in this data and we actually want to graph it in Excel, just go ahead and copy and paste that raw data. Go into Excel. Here you can see I've already done this. So the first thing I might want to do is sort my habitat between grassland and oak woodland to make it easier to work with. So I'm going to go ahead and select all of this. I'm going to do Control click or a left click, depending on if you're a Mac or a PC user, and do sort A to Z. Tells me expand current selection. In other words, it's asking me, for instance, for this row 2, oak woodland, should also sort so that 40, 28, and 26 travel with this cell. So I want to say yes, expand the selection so that it does that. Hit sort, and it sorts it out very nicely for me. So what I often do when working with data where I'm doing some sort of summary is I'll create a new tab for my summary data or a new sheet. So here you can see I've labeled this my raw data, this is my summary data, and I've already set this up in a table for calculating some summary statistics. So the first thing we're going to want to calculate is the mean or the average of this vegetative cover, because that's what we're going to be graphing. So I'm going to say equals average, which is the function for Excel for this, and I'm going to go ahead and I'm going to select here everything where it says grassland and hit enter. And it's automatically calculating that mean for me. I am going to make sure that it's always selecting this data chunk when I'm working with grassland data. So I'm just going to put those dollar signs in front of it. And I'm going to do the same for the oak woodland. So equals average. Go in here for my raw data, select through, enter. Okay. And I'm going to put those dollar signs in again so that it's this absolute reference, not relative reference. I'll show you why in a second. You'll notice that because I'm working with data in a different spreadsheet, before it shows you these rows and columns, it's going to show you the name of the sheet in this format where it has the quotes around it and then the exclamation point afterwards. So now I'm going to copy this over and I'm going to do equals stdev, and that's where I can just have really efficient entry by having that copied over those absolute references. I can do equals count, which is going to tell me the length of this for my sample size, so 37. And then my standard error of the mean is going to be equal to my standard deviation divided by the square root, which in Excel is SQRT, of my sample size, 37. I'm going to hit enter. And next thing I'm going to want to do is do that for the oak woodland. So again, I'm going to copy this over. Equals stdev, enter. This is equals count. You'll notice sometimes it'll do these other things like count A. Just go for the most simple version, count. Enter. And for this one, since I have a relative reference, what I can do is drag this down. And you'll notice it's giving me a different number. It's because since I didn't put those dollar signs, as I dragged this cell down, it referenced the next cell down itself. Okay, so now I have these summary statistics, and I want to actually start graphing this data. So what I'm going to do is, going to go to Insert. Has all these recommended charts. You can do that, or you can go to this. So I'm going to put this chart in, and I'm going to say Select Data. So first off, so my X values are going to be my habitat types. So I select those, and I'm going to call them habitat. Okay. And select data. Oops, sorry guys, messed that up. my X values. So I'm going to select habitat, and horizontal or X category labels are going to be habitat. My Y values, my response, is going to be this mean vegetative cover. And there we go. Hit OK. Okay, so the next thing that we're going to want to do is actually graph this data. So what I'm going to do is I'm going to select this habitat and mean vegetative cover. I'm going to go over here to recommended charts and just click this top one. So this is a basic bar graph. I am going to want to do a couple things to make this a publication quality graph. So first up, I'm going to want to click these grid lines and get rid of them because those are actually kind of distracting. I'm going to get rid of this title because really what we want is a figure caption, and you can just go ahead and write that in Word. I'm going to delete that. I can do things like formatting this axis. So you can change the minimum and maximum. Like, it wouldn't make sense for this to go beyond 100 because it's percent. I can change the major units, so they could be in 20s or whatever. So that's how you can modify those. And I can choose to add in a line, which is really common. I don't know why the automatic presets in Excel don't have that line already built in, but they don't. So you're going to want to do that. Okay. I can go ahead and I can do the same over here. So I can format this axis, and I can do something like, I want this to have an automatic line that is the same color as that. Great. And I could do something special like the grassland. Maybe I'm going to make this a different color. I'm going to make it green for grass, and our oak woodland, maybe I'll change that fill so that it's a really dark green for oak trees, whatever you want to do. I'm okay with you guys doing solid fills. Don't do a bunch of hashing fills and things that are distracting. And also think about your color choice. If we're doing hot versus cold, you might want to do blue versus red. Make sure your colors make sense and are actually adding to your graph. Okay, so the next thing we're going to want to do is go to this upper left. We're going to add in axis titles. So here, I'm going to call this percent vegetative cover. Another thing you could just do is do vegetative cover with the percent at the end. Saves a little space. That's a common thing that people do in publications. Anything to save space. I'm going to add in another axis title over here and do habitat. And the one other thing that I really want on this graph is some measurement of how confident are we that this is actually the mean vegetative cover within a grassland and the mean vegetative cover in an oak woodland. So I'm going to go over here and I'm going to say error bars. Now, one thing I could do is just automatically let it calculate these error bars. So let's do that. Let's take a look at this. Notice that the standard error here that it's giving is the same, which doesn't seem to be what's actually going on in our data. So the way that Excel automatically calculates our standard error of the mean is taking the standard error between this value, the grassland, and the oak woodland, which is not what we want. We want the standard error around this grassland vegetative cover and the standard error around the oak woodland. So there should be two different error bars. So I'm going to undo that. So the way that we do it the nice way is going into chart element, error bars, say more error bar options, and we're going to go to custom. So over here, I'm going to select this, Oops, gonna have to do that again. So error bars, more error bar options, custom, specify value, and it's going to ask for both a positive and a negative. So if you just wanted a positive, you just put that in and it's only going to show your error bar above. But it's most common that you'll do the error bars above and below. So to show you that again, error bars, more error bar options. Here, you can choose whether you want to have a cap or not. That's really common. You can choose if it's just going to be both or one way. So again, I'll specify the value. I specified the positive, and I will specify the negative. Hit OK. And now when we look at this graph, you'll see that the standard error of the mean for our oak woodland is a lot bigger than the standard error of the mean for our grassland, which matches our calculations. So that's great. That's what we would expect. And I can even be super fancy and go ahead and change this. Okay, so now we have a really nice informative graph. The last thing that you're going to want to do is create a figure caption for it. So for instance, I can go in, ignore my documents. Here, I'm going to paste in my graph. And I am going to say figure 1. And the first sentence is something informative about the graph. So I am going to want to say percent vegetative cover in, let's say, central, no, let's just say grasslands versus oak woodlands in Holly Canyon Village, San Luis Obispo, California in April. And I'm going to want to say what our sample set, let's actually just leave it at that. So I've said, okay, what are we looking at? Percent vegetative cover, so our response against what's going on in our x-axis. And since we have some reason to believe that maybe this vegetative cover depends on location, so vegetative cover is probably different in Seattle or New England, so I'm going to say where this is, and it probably changes over time. We just had a lot of rain, so maybe there's more vegetative cover than there normally would be. So April, and to make this even better, let's say 2019. Oops, I can type. Okay, so the next thing I'm going to want to do is explain what these error bars are. Most common way that's done is error bars show, you can either do SE for standard error or SEM for standard error of the mean. And then we want to say how big our sample size is. So oftentimes you'll see that N equals 37 quadrats per habitat type. So that's how this is commonly written up. Okay. And last but not least, every time you guys are making one of these graphs, you're often going to be asked to say, okay, so you made a graph. What is it telling you? Interpret this visually. So if we ran a t-test, we can see that these error bars really do not overlap. So there's probably, there's very likely, significantly higher vegetative cover in the grassland versus the oak woodland. So you might want to describe, okay, how did you come to that determination that it's very likely that there might be higher mean vegetative cover over here. Later on, we'll teach you how to actually do that t-statistic that we would use to validate that. But for now, describe the eyeballing procedure that you used. And then, what's a good biological explanation for what might be driving that difference in ground cover between this grassland versus oak woodland? All right. So that's the end of our screencast today. When we get into R, we'll continue doing these screencasts for how we plot these graphs.